Welcome to Networks Professionals.
Welcome to The Explainer. I am absolutely thrilled you're joining me today. We are going to take a really fascinating, structured look at a brilliant piece of technology working behind the scenes in IT. We'll be exploring exactly how corporate networks survive catastrophic hardware failures without dropping a single connection. Seriously, it's this amazing story of resilience, clever engineering, and a protocol that acts kind of like an understudy waiting in the wings.
So I want you to picture this for a second. You're in the middle of a critical video call with a major client, or maybe your system is right in the middle of transferring these massive, time-sensitive financial files, and then boom, the primary router in your office building just completely dies. Maybe its power supply fails, or a critical component shorts out. What happens to your connection in that exact split second? Absolute panic, right? I mean, in a traditional setup, everything just stops. The screen freezes, the transfer fails, and everyone starts frantically scrambling. The real-world stakes of network stability are massive.
Okay, let's dive into this. On the agenda today: 1. Single point of failure. 2. Enter HSRP, the hero. 3. Active, standby, and listen. 4. Elections and hello messages. And finally, 5. The preempt takeover.
Kicking things off with Section 1, Single Point of Failure, the IT Nightmare.
This right here is literally the ultimate IT nightmare. In a basic network design, all your end devices are pointed to a single default gateway. It relies on one piece of physical hardware. If that router dies, the connection is instantly severed for every single endpoint. It is a terrifying bottleneck for any organization. Moving on to Section 2, enter HSRP, the hero, high availability. Meet our solution, HSRP, which stands for Hot Standby Router Protocol. This is a Cisco proprietary protocol, and honestly, you can think of it as the ultimate insurance policy for your network data. It was specifically designed to ensure high network availability by doing one incredibly important thing: creating a redundant default gateway. It takes that terrifying single point of failure we just talked about and completely engineers it out of existence. Now, the way HSRP actually achieves this redundancy is through a virtual IP, or a VIP. Instead of pointing your computer to the physical IP address of a specific tangible router, you point it to this VIP. This virtual IP is basically a phantom gateway. It's a single shared IP address that is assigned to multiple physical routers simultaneously. The best part? The endpoints have absolutely no idea they're talking to a virtual concept rather than a physical box. Let's look at the brilliant sequence of events that actually happens during a crisis. This is what we call the seamless switch. First, all your end devices are happily sending data to the VIP. Then, disaster strikes. The active physical router drops dead. But in a fraction of a second, HSRP dynamically maps the virtual MAC address to a secondary backup router. The physical box processing the data changes instantly, but the virtual address the computers are talking to remains exactly the same. So the crucial point here, and this is a real game changer, is zero client reconfiguration. Because the computers are talking to the virtual IP, and the virtual IP simply moved to a new physical router behind the scenes, the user devices don't even notice the crash. The video call might drop a single frame, or that massive file transfer might pause for just a microsecond, but it survives. It requires absolutely zero manual fixes. There's no IT team sprinting down the hallway with cables, and zero panic.
All right, Section 3, Active, Standby, and Listen. HSRP router roles.
I actually love to use a theater metaphor to explain this part. On one side, we have the active router. This is our lead star on stage, standing right in the spotlight. It's actively forwarding the data packets for the connected endpoints, doing all the heavy lifting. On the other side, we have the standby router. This is our understudy. It's waiting eagerly in the wings, listening closely for status updates, fully prepped and ready to instantly jump on stage and take over routing duties if the lead actor so much as coughs. But, what if you have a massive production and you want way more than just one backup? Well, HSRP accommodates that with the listen state. Any additional routers in the same HSRP group just sit in this state. They're kind of like the extras in a play. They aren't the lead, they aren't the primary understudy, they are simply sitting in the wings, passively monitoring the situation. They aren't forwarding traffic at all, but they're there as a third or fourth line of defense just in case everything goes terribly wrong.
That brings us to Section 4, Elections and Hello Messages. HSRP communication.
It really all comes down to a tiny, constant heartbeat of communication, represented here by the number 3. The active and standby routers continually exchange what are called hello messages, and they do this every 3 seconds. It's essentially the active router calling out into the dark saying, "Hey, I'm still here, I'm still alive." If the standby router stops hearing those hello messages, well, it knows the active router has failed and it's showtime. But when you first plug these routers in, how do they actually decide who gets to be active in the first place? That brings us to the number 100. Routers elect the active role based on their HSRP priority score. Out of the box, every single router is assigned a default priority of 100. The router with the highest score wins the job. Of course, a network admin can always go in and manually change this score to ensure their strongest, newest router always wins that active role.
And this brilliantly illustrates the simple, unarguable logic of the system. The election process is really just 2 steps. Step 1, compare the HSRP priorities. The highest priority wins. But what if the network admin just left them all at the default of 100? Well, step 2 is the tiebreaker. The router with the highest physical IP address automatically wins. This incredibly simple mathematical logic prevents routers from arguing over the active role and stalling out your network. Let's wrap things up with Section 5, the preempt takeover, reclaiming the role.
So, what happens when that original router is fixed? This is handled by a feature called preempt. Preempt is an optional configuration. It's a special rule you can turn on, allowing a router to forcefully reclaim the active role if it comes back online after a failure, assuming, of course, it has a higher priority than the router currently doing the job.
To go back to our theater metaphor for a second, this is literally the diva lead actor recovering from a cold, marching right onto the stage mid-scene and forcefully kicking the understudy back into the wings. Without preempt turned on, the understudy would just finish the show, meaning the backup router would keep forwarding traffic until it failed. But with preempt configured, the exact moment that high-priority primary router is plugged back in and boots up, it aggressively steals the spotlight back and resumes its routing duties. We've seen how HSRP uses virtual IPs, understudy routers, and 3-second heartbeat messages to ensure your data never stops flowing, completely masking hardware failures from your end users. It really is a masterclass in redundancy. But I want to leave you with this provocative thought as we wrap up today. If we can engineer a solution this elegant to mask router failures in just 3 seconds, what other single points of failure are currently hiding in your network just waiting to bring everything to a halt? Take what you've learned here today, go audit your systems, and keep building incredibly resilient networks. Thanks so much for joining me on this explainer, and I'll catch you next.
Thanks for watching.